Okay, this is 7th grade, 7.1.2, and it is called How Can I Make It Smaller or Bigger? So we're scaling quantities. It says in Chapter 5 you learned how to find the percent of a number by making a diagram to relate the part to the whole and find the desired portion. This calculation is fairly straightforward if the percent is a multiple of 10, like 40%, or can be thought of as a fraction like 1/4 is 25%. However, it can be more challenging if the percent is something like 6.3% or 84.5%. So today you will connect what you've learned previously about the relationship between distance, rate, and time to the idea of scale factors. You will learn how to use a scale factor to find the corresponding lengths of similar figures. This idea will add a powerful new tool to your collection of problem-solving strategies that will help you to calculate percents. So 716 is where we're starting. And it says Dana is training for a bicycle race. He can ride his bike 25 miles per hour. One day, when he'd been riding for 3/5 of an hour, he had to stop and fix a flat tire. How many miles had he ridden when he stopped? So then it shows you this diagram. It's got 1, 2, 3, 4 dashes in it, and then it has like the little thing. Sorry, that looks really weird. And it says 3/5 over 1, 2, 3 of the parts and a question mark. And then it says 25 miles and it says 1 hour. So it says how many miles had he ridden when he stopped. So here's where he stopped. And we want to know how many miles fit inside of this 3/5. And we're doing a total of 25 miles because that's how much he can go in an hour. So what I did was I thought, well, I remember when we did stuff like what is 3/5 of a number, I thought, well, what is 3/5 of 25? And remember when we see of, we know we want to multiply this quantity by that quantity. So if I go ahead and do that, 3/5 times 25 over 1, multiplying fractions just means you multiply across. So 3 times 25 is 75, 5 times 1 is 5, and this can reduce. 5 goes into 75 evenly 15 times. That means that he had gone 15 miles before he stopped to fix his flat tire. So 15 miles is 3/5 of 25. And moving along to 717. To scroll down. Matt thought about that last problem and drew this diagram. So he drew a triangle and he put original inside of it, and then he drew a smaller one but looks very similar to this one. Then he has 25 miles over here, and then he has a dot here, which means multiply, and it says 3/5, which is what we did in the previous problem, and then it has an arrow. So it says and it says x right there. A says write an equation that uses the scale factor to find x. Now you might be wondering what the scale factor is for this problem. The scale factor, when you're scaling something, so this is the large triangle and this is its like duplicate, but it's a smaller image. It's a smaller version of it. So you multiply this side. We're trying to find this side of the triangle over here. And we know since the triangles are related, they're similar triangles. So that means that I can multiply something by this 25 to get that x. And our scale factor for this problem is 3/5. So that's our scale factor, what we multiply one side by to get the corresponding side. So this side corresponds with that side. Write an equation. Okay, so the equation is what we wrote. So this is part A of 717. It's the same thing we wrote in the last problem. 25 times 3/5 equals x. That's our equation. So then part B says, what connection is map making between finding a distance using the rate and time, like we did with the bike problem in 716, and using a scale factor with similar figures? How are the situations alike and how are they different? Well, I was just thinking that he used a total number of something. So he used a total number. So in this case, it was 25, and in the last problem, it was still 25 of something. And then what did he do with it? He multiplied it by a fraction, which was 3/5, to get a smaller number or a smaller portion. So I put, or triangle, so I put slash triangle. Because when we went from 25, we took 3/5 of 25, which was 15, and so that's a smaller number. So when you multiply by a fraction, when the numerator is smaller than the denominator, you're going to come out with a smaller product. So our smaller product was 15. Use total something, multiply by a fraction to get a smaller number. So that's the idea of scale factors. You're taking something bigger, multiplying it by a fraction to make it that side smaller. Okay. 718 says in the two previous problems, 3/5 is used in two ways. First, as time, so it's used as time in the first problem, 25 miles. So it says 25 miles per hour, or 1 hour, times 3/5 of an hour. And the second problem, we used it as a scale factor to find the 3/5 of 25. Of 25 miles. Both of these situations resulted in an equivalent calculation. They both ended up 25 times 3/5 equals 15. How else could this be written? So it wants you to look at the portion web, and we've worked with the portion web before, and it's drawn right in your book. And I will make one here, kind of to the side. So it goes like this, and it goes like that, and it has fraction up top, decimal down here, percent down here, and then it's all interconnected. Fraction, decimal, percent. So for this part A, it says, using the portions web, work with your team to find two other ways to write this equation. 25 times 3/5 equals 15. Now, at first you might be like, okay, I don't know what they're talking about, but it says, for example, one way might be 25 times 6/10. And they did that because you can make 3/5 into 6/10 by timesing top and bottom by 2. And that's equivalent, so that matches. This is the same thing as this. So I'm going to erase their example, and we're going to come up with two different ways to show this equation with a decimal and a percent. So our first one, let's do decimal. So what you need to do, if you don't already know, you need to plug 3 divided by 5 into a calculator to get your decimal. And the decimal ends up being 0.6, and that's the decimal part. So the decimal's done, the fraction's done. Now we need to do the percent. And the percent, you just want to look at the decimal, right? Because when you're changing a decimal, 0.6, into a percent, you move that decimal over to the right two times because you're multiplying this by 100. And then you get 60%. So 25 times 60% is 15. So there's our two other ways of writing that equation. Okay, looks good. So we know that 3/5 is 60%. So that was A. B says, if you did not already find it, what percent would be equivalent to 3/5? And we just found out that 60% is equal to 3/5. And it says, use this percent to write a statement in words and symbols that's equivalent to 25 times 3/5 equals 15. So we're going to write a sentence or a question. I actually wrote a question, and I've already written it earlier. So my statement is going to be, what is 60% of 25? That is the same thing as writing what is 3/5 of 25 and what is 0.6 of 25. So that's part B. And then part C says, use the idea of scaling to find the following values. Write an expression using either a fraction or a decimal. And actually, I'm going to erase this so I have more room. So it says we have three little sub problems here for C. So we have the little I thing, and it says 90% of 25. And it wants us to write using either a fraction or a decimal and then find the actual result. So I'm going to write it as both a decimal and a fraction because we're able to do that. We can do that. So if I wrote 90% as a decimal, it would be 0.9 times 25. And then I put that in my calculator and I got 22.5, 22.5, jeez. And then my next one was the fraction, so I just did 9/10 because that's the same thing as saying 9/10 times 25, which is the same thing, 22.5. Okay, so there's our two different ways of writing it, and the result is 22.5. So that's this first little sub problem of C. Here's the second one. There's a little two I's, and it says 8% of $75. Okay, so let's write it as a decimal. So be careful with 8% because a lot of people might put 0.8 as 8%, but that's actually 80% because you move the decimal over twice. So if I want to make a percent into a decimal, I'm going to take this decimal point, it's invisible right to the right of the 8, and move it to the left 2 times. So now it moved over there. So that would be my decimal for 8% times 75, and I put that in my calculator, and it was $6. If I wanted to write this as a fraction, I can kind of read it because I know this is the tenths place, this is the hundredths place. So I know that this says 8 hundredths times 75 equals $6. And that is the second subproblem of C, and the third subproblem of C has the three little I's, and it says 25% of 144. Okay, same deal. Let's do decimal first. So 25%, we just move that decimal to the left twice to make a decimal. So it becomes 0.25 times 144. And I plugged it into my calculator and got 36. And to write this as a fraction, you could do 25 over 100 because it's 25 hundredths. You could also reduce that if you wanted to, because 25 over 100 is the same thing as saying 1/4. 1/4 times 144 is 36. Okay. One more problem. 719. And I don't think we need that anymore. Now it's bringing in going out to dinner. So it says, Hosea went out to dinner at an Indian restaurant. The total bill was $38. The total bill is $38. She wanted to leave a 15% tip. So I'm writing down the total bill, $38, tip. She wants to tip 15% of that $38 as the tip for the waiter. So it says, if you use the idea of scaling to find the tip amount, what would she need to multiply by? Consider these questions, and then we're going to go through each of those bullet points. So it says, how could you represent this multiplier as a fraction? So the multiplier is just the scale factor we've been talking about. It's going to be this percent, and that's our multiplier. So they kind of interchange those words. They go from saying it's a multiplier to a scale factor, so it's good to know that that just means the same thing, multiplier, scale factor. So here we go. How could you represent 15% as a fraction? Well, if I change it to a decimal first, it might be easier to look at it as a fraction. So if I want to change 15% to a decimal, I take 15 and move that decimal to the left twice. So now I'm left with the decimal 15.15, which is actually 15 hundredths. So there's our fraction for the first bullet point. We already answered the second bullet point because it says what is this as a decimal? 0.15. Does it make a difference which representation, fraction or decimal, you use to solve it? And I said no, because they are all equivalent. It's going to be the same no matter what representation you use. If you use the fraction, if you use the decimal, it doesn't matter. So I almost put not matter, but doesn't matter. They're all equivalent. Last bullet point, how or which do you think will be easier? And that's what I was thinking too. I was thinking, well, if I'm at a restaurant and I've got my phone with me, and I've done this plenty of times before in real life, you want to figure out the tip, you go into your calculator, put in the total amount of the bill, and then you use multiply, and then you put the decimal in. So I said the decimal is easier because it's a lot easier to calculate with decimals on a calculator than it is with fractions, in my opinion. So decimal would probably be easier to calculate. And if you had paper at your table, you could easily do 0.15 times 38 if you could. If you didn't have your phone, which would be really weird. Be how much should she leave for the tip? So let's figure out how much she should leave. So we're going to write our equation, which is 38 times 0.15. I'm going to use the decimal, and I'm going to try it without a calculator this time because I don't feel like getting my calculator out. So 38 times 0.15. So when you're multiplying a whole number in a decimal, multiply as usual, and then we'll take the decimal into account at the end. So 8 times 5 is 40. That's 15 plus 4 is 19. Bring down to 0. That becomes 8. That becomes 3. 0, 7, 5. Last part, we see that the decimal is 2 times over. So we move it 2 times over, and the tip to leave would be $5.70. Part C says, I guess I'll erase it. Part C says, if she changes her mind and wants to leave a 20% tip, so instead of 15, she does 20%, how much will this be? So same idea, 38 times, and then we know that to change 20% to a decimal, we take 20, move the decimal over twice, so it becomes 0.20 or just 0.2 equals, and I'm going to do it again just mathematically like this. 8 times 2 is 16, 3 times 2 is 6, 7. Move the decimal over once, and you're left with $7.60. Make sure you leave it 60 cents because we're using money here, so it does matter if you put that 0 at the end. So she leaves about, what, $2, about almost $2 more of a tip if she tipped 20%. That is the end of this lesson, and that's it. Okay, goodbye.